Hi guys, so today I'm just going to go through the different methods we've learned to solve for sides and angles throughout Unit 7. So the first thing that I'm going to talk about is the Pythagorean Theorem. The Pythagorean Theorem states that the leg of a right triangle squared plus the other leg of a right triangle squared is equal to the hypotenuse squared. So this is where we have a squared plus b squared equals c squared, but again, remember that c has to be the hypotenuse. So we use the Pythagorean theorem when we're looking for the missing side of a right triangle. We're looking for the missing side, and we have to be given two of the sides. Okay, so we're looking for the missing side, and we have to be given two of the sides. The next thing I want to talk about is our special right triangles. We have two special right triangles. The first is our 45, 45, 90. And the other is the 30, 60, 90. We use our special right triangle ratios to find missing sides. But again, we have to know that we have the 45, 45, 90, or we have the 30, 60, 90 triangle before we can use those ratios. So with our special right triangles, that is where we set up our charts. For the 45, 45, 90, we will have leg, leg, hypotenuse. And if you think about it, we have two of the same angles, so we're going to have two of the same variables when we set up our chart. The 45 and the 45 angles are the same, therefore the leg and the leg will be the same. You're going to have the new triangle over the parent triangle. And the parent triangle numbers are 1, 1, and radical 2. Again, the legs are the same, so these numbers will be the same. And keep in mind that both of our special right triangles, our ratios contain one radical. So for the parent triangle, we have 1, 1. This 2 has to have the radical over it. For the 30, 60, 90, the headings are going to be different because they have three different angles. We have the short leg, the long leg, and the hypotenuse. And for the 30, 60, 90, the parent triangle is 1, radical 3, and 2. Again, we have just one radical here. Remember, this is 1, 2, and 3, but the 3 is going to have the radical in it. So in these two instances, the same number does not contain the radical. So if you're having a difficult time keeping straight the numbers that go with each triangle, listen to these different tips and keep them in mind. So when we solve for special right triangles, again, we're looking for missing sides. But we have to know that they're either a 45, 45, 90 or a 30, 60, 90. If you don't have any angles, you cannot make assumptions that the angles are these measures. From there, we set up the proportion, we cross multiply, and solve for the variable. Then we have SOHCAHTOA, which we also use to solve for missing sides. So right now, I'm just talking about using SOHCAHTOA to find missing sides. In order for us to use SOHCAHTOA to find a missing side, we have to have at least one of the acute angles in our triangle. Okay, we must have at least one of the acute angles in our triangle. From there, we have to identify the sides with respect to that angle to determine if we're going to use sine, cosine, or tangent. Remember, sine is equal to the opposite side of that angle divided by the hypotenuse. cosine is equal to the adjacent side of that angle divided by the hypotenuse, and tangent is equal to the opposite side divided by the adjacent side of that angle. So again, whatever that reference angle is, whether it's here or here, it doesn't matter which one, you just have to make sure that you're identifying your sides appropriately. So in order for you to find those missing sides, you have to have at least one side. You have to have at least one side length, and you have to have at least one acute angle. Okay, we already know that this is a right angle. We only use this with right triangles. We know that that's a right angle. We have to have one of the acute angles as well. Okay, that's what we use to find missing sides. So those, we have Pythagorean Theorem, we have our 30, 60, 90, we have our 45, 45, 90, and we have SOHCAHTOA, which are the 4 methods that we'll use to find missing sides in this unit. Now the other things we have are to find missing angles, and we have 2 methods to find missing angles. The first method is the triangle angle sum. Okay, we use this to find missing angles. And this tells us that the sum of 3 angles is 180 degrees. Okay, the sum of and this is interior angles, in a triangle is 180 degrees. But we must have 2 of the 3 angles. Okay, we must have 2 of the 3 angles to find the missing angle using the triangle angle sum theorem. The other method that we have to finding missing angles is SOHCAHTOA. Now this is strictly when the inverse of our trig functions is involved. We only use the inverse when we're looking for missing angles. So in order for us to find missing angles, so we'll just call this theta. Remember, we could call it A, we could call it theta, we could call it question mark, whatever it is it's labeled as. If we're looking for missing angles, we must have 2 side measures in order to use this. If we have 2 side measures, we can use SOHCAHTOA to find this missing angle. Again, we would have to take a look at the sides that we have with respect to this angle. Here would be adjacent, here would be hypotenuse, and that would tell us which of the 3 functions we have to use to solve for that angle. In our work, though, we have to show that we're using the inverse to find that angle. So that's just a summary of Unit 7. I hope you find that helpful.